Right, so this is the topic of proportion. There are two types of proportion. One is called direct proportion, the other is called inverse proportion. I'll explain that when I get to it. But the idea is proportion is very much like saying things are equal, but there's some sort of multiply or divide that must always happen. I think questions 1 and 2 you'll probably be fairly familiar with from primary school and from year 7, but I will take you through the method just quickly. Suppose I had 4 calculators cost me £32.80. I'll assume they cost the same amount each. Then I should be able to work out how much 9 calculators cost. So I start by making a little equation. I'm going to say that I know 4 calculators cost £32.80. And ultimately the question is asking me how much do 9 calculators cost. So it's going to be more, isn't it? It costs, if I'm buying more calculators, it costs more money. But even though the question says 9, I'm just going to take it down to 1 calculator first. So for every single question, I'm going to drag it down to 1 and then up to the number that it's actually asking for. So to get 1 calculator, I need to divide by 4, don't I? Let's divide both sides by 4. Now, some of these questions you may use a calculator for, others you can't. There's a mixture. This one's not too bad in our heads because I know 32 divided by 4 is 8, and 80 pence divided by 4 is 20. There's £8.20 per calculator. So to get up to 9 calculators, I'm going to multiply by, get my grammar good, multiply by 9. Okay, multiply both sides by 9 to get the total amount of money for 9 calculators. 9 times 8 is 72, and 920p's is £1.80. This is £73.80. Feel free to use a calculator if you couldn't do that in your head, though. So in question 2, a similar sort of idea, I'll start by writing an equation. So I've got some bottles of liquid here. Maybe it's milk, maybe it's pop, I don't know what they're bottles of, but when you've got 3 whole bottles, that contains 600 millilitres. So 3 bottles is 600 millilitres. Okay, 3 bottles, 600 millilitres. And the question is saying, well, how much would be in 7 bottles? And so eventually I want to write 7 bottles equals, but I'm going to take it down to 1 bottle first. Okay, let's take it down to 1 first. Now to get from 3 bottles to 1 bottle, that's just divide by 3. So divide this by 3 as well. That's easy in my head. 600 divided by 3 is 200. And if I want to know 7 bottles, that's multiply by 7, isn't it? Multiply both sides by 7. 200 times 7 is 1400 millilitres. So multiply both sides by 7 there. Okay. Now, question number 3 is a little bit different, and this is where I expect it'll probably start to be a bit more complicated for you. The idea is I've got a particular amount of work that needs to be done. There's a particular job, and when I've got 5 people doing it, they can get it all done in 60 days. And I'm going to assume that they all split the work evenly between them. So the question is, how long would it take 15 workers? Well, that's more people, and here's the thing, you're expecting more people to take less time. If there's more people helping, the job time will go down, you would expect. That's different to what we had before. Previously, if you bought, say, more bottles, then you got more millilitres, right? So 3 bottles was 600, but 7 bottles was 1400. So as one number went up, the other number went up as well. That's what we're calling direct proportion. Whereas down here, it's the other way around, isn't it? So 5 workers, if I have more people helping, you'd expect that to take less time. As one number goes up, the other goes down. And the name for that type of proportion is inverse proportion. Right, let's actually deal with this question then. So I've got 5 workers can do the job in 60 days. Now, eventually I want to write 15 workers equals, but I'm going to use the same method as before. Let's take it down to 1 worker. Now, if 1 worker was doing this all by themselves, they would need more time. Okay, it takes longer for 1 person to do all the work than if 5 people are doing all the work. I think that should be fairly obvious. 5 people all helping, you get the job done quickly in 60 days. But if one person has to do it all by themselves, that will take far longer. So if you've only got sort of 1/5 of the workforce now, it's going to take 5 times longer. So the most common mistake here is people divide by 5, mistaking it for the type of question we've done in 1 and 2. But no, it will definitely take one person longer to do it by themselves. So 60 times 5 is 300. So it would take ages if one person was doing it all on their own. But the question says there's actually 15 workers, so that's a relief. There's 15 times as many people helping now than when it was one person. And if you've got 15 times as many people helping, it will take 1/15 of the time. They can do it faster. So 15 times as many workers. Let's divide this by 15 to see how long that takes. Again, this is fairly easy without a calculator. I know 30 divided by 15 is 2, so this is 20 days. So I've done the method again where you take it down to 1, first of all, 1 worker, and then take it back up to 15. In this question, there was a shortcut. If I just reset to the opening line again, 5 workers, 60 days, you might have noticed that 15 workers, to get from here to here, I've multiplied the workforce by 3. Okay, that's 3 times as many workers, but this is an inverse situation where more workers will take you less time. So if you can notice that to get from 5 to 15 with times by 3, I can just divide this one by 3 directly. So 60 divided by 3 is 20. And notice how we've got the answer, same answer, because that was the correct answer there. But we've done it much faster because we noticed this little shortcut that it was 3 times as many people. But you don't have to notice it. This method where you take it down to 1 first will always work. I'll show you another example that's like this, that's inverse. So this one is very similar, but it does have like an extra number in it just to make things confusing. The idea is that we're in a factory which makes cars. So we make 1,200 cars, but it would take 6 machines 48 hours to do that. So when all 6 machines are working together, they can do the job in 48 hours. I want to know, still making the same number of cars, but with fewer machines, how long would that take? Right, so I'll say that again slowly. We've got this situation where there's an amount of cars that's the same in both. So there's like a certain job that needs to be done. If 6 machines are all working hard all at the same time, then I can do this job of making those cars in 48 hours. But what if I only had 4 machines? Then how long would it take? So this is an inverse proportion question because you would expect fewer machines to take longer to do the job. If you had more machines, they could do it faster. So let's do it like this. We've got 6 machines take 48 hours. Now I know the question says how about 4 machines, but let's take it down to 1 machine first. So if 1 machine was doing it all by itself, that's going to take a lot longer. Okay, 1 machine will need more time to do it all alone. And so let's multiply this by 6, because you've now only got 1/6 of the workforce. So let's multiply this by 6. So on my calculator, we'll do 48 times by 6, and that comes out as 288. So 288 hours if we only have 1 machine doing it all by itself. But I don't have 1 machine. The question says, what if it's 4 machines? So 4 times as many machines now will be able to do it in 1/4 of the time. So more machines, less time. So divide that by 4. And I should be able to do this in my head. If you halve that and halve it again, that's 144, then 72. But again, feel free to use a calculator by all means. So the situation we had here then was that when 6 machines are all working together, it took 48 hours to do the job. 1 machine would take longer to do it by itself, but when you've got 4 machines doing it, it would take 72 hours. Notice how that's longer than the 48, as it should be, because 4 machines is fewer machines than 6. You'd expect 4 machines to take longer than 6 machines. That's less workforce, that's less help to do the job. The number 1,200 we didn't really use in this question because it was the same in both. So to summarise, the idea is that some questions, as one number goes up, so does the other number. That's like questions 1 and 2. If you buy more calculators, it will cost you more money. So 9 calculators cost more than 4. If you buy if you have more bottles of drink, then you've got more millilitres. So 3 bottles was 600, but 7 bottles was 1,400. So obviously more because there are more bottles. As one number goes up, so does the other number. That's what's meant by direct proportion. As one goes up, the other goes up. If one goes down, the other goes down. So if I bought fewer bottles, if I only bought 2 bottles, that would only be 400 millilitres, wouldn't it? So as one goes down, the other goes down. That's direct proportion. Whereas in number 3 and 4, the situation was different. Can you remember the answer? It was 20, wasn't it? Yeah, when we had 5 workers, it took 60 days, but 15 workers only takes 20 days. If you've got more people helping, then it takes less time. We will assume that they're not all going to get in each other's way. We'll assume that everybody is contributing equally, and that if you, for example, double the workforce, it will take half the time. There are some real life situations where that wouldn't work because for certain jobs people would just get in each other's way, like too many cooks spoil the broth. But we'll assume for the purpose of these questions, in all of them, that they're working equally, and if you have more workers it will take less time, but fewer workers will take more time. That's an inverse situation because as one number went up, the other number went down. So perhaps the biggest difficulty with these questions is when you read them, when they're all mixed up, is, well, which one is it? Is it a situation where as one number goes up, the other one goes up as well, direct proportion, or is it the situation more like question 3 and 4, where as one number goes up, the other one goes down? Unfortunately, you just have to read the question carefully. Just fully read it, try to think about it, and then is your answer logical at the end? So we were given that 6 machines do a job in 48 hours, and our answer that we worked out was that, if I just put it back in, that 4 machines take 72 hours. I think, well, yeah, that does make sense. 4 machines is less than 6, fewer than 6 machines, so surely it's going to take longer. And then you just puzzle it through. And if you end up with a nonsensical answer, if you end up with something like, 2 bottles of shampoo cost a £5, but 10 bottles of shampoo cost £1, you think, well, you must have made a mistake there. So always think about the reasonableness of your answer at the end. Apologies if this video was a bit strange, if it jumped about a bit. It's because I was recording it whilst also trying to do the Google Meet live, because for some reason I couldn't record the Google Meet, so I did this on my phone. So hopefully it did make sense in the end. Okay, good luck with these.